Hello everyone, Pam here again. I hope you are doing well wherever you are, and welcome to this video. So recently I've been thinking, and if you've been following this channel, you know I've been concentrating on the practical hacking of mobile applications. That is analyzing code, breaking through defenses, bypassing protections and so forth. And recently I realized most people watching might be jumping in at the deep end. That is like teaching someone how to escape a burning building before they even know how the walls were constructed. So I've decided to shift gears and start from the beginning, the foundational aspects of secure mobile app development, how we design, build, and secure applications from day one. You can think of this like trying to fix a leaking roof. So if you understand how the roof was built, its materials, angles, and connections, you'll not only find the leak faster, but you'll fix it without breaking something else, like the electrical system. So that's the mindset we need to have for mobile security, and that is understanding how it all fits together. And the perfect starting point for this journey is none other than OWASP Mobile Top 10. As at 2025, the list is of 2024. So this is the most current and community-driven list of mobile app security risks that every developer, tester, and architect needs to know as at this date. We start with mobile risk number 1, which is improper credential usage. This is a major issue found in real-world applications with sensitive credentials like API tokens, passwords, or secret keys are hard-coded into the source code or stored in plain text in application files. These secrets are normally low-hanging fruit for attackers who can reverse engineer applications, especially on Android where APK decompilation is very trivial. Credentials should therefore never be stored in code or in secure storage areas. Instead, we should use enclaves like the Android keystore or iOS keychain, and we should actually try to implement runtime secret fetching where appropriate, especially things to do with key vaults such as Azure Key Vault. Then comes number 2, which is inadequate supply chain security, which is all about trusting too much in third-party dependencies and SDKs. Modern applications are stitched together with dozens of external components, as you know, from analytics to payment libraries. And if just one is malicious or vulnerable or misconfigured, then your entire application is at risk. We therefore need to verify signatures, scan dependencies, maintain SBOMs, and lock dependency versions in order to defend against supply chain attacks. Number 3 is insecure authentication and authorization. Whether it's a broken login flow, insecure token management, or missing role checks, any weakness in how your application identifies and grants access to users can lead to impersonation, privilege escalation, or unauthorized access to sensitive functions. Authentication must be strong, and if an application has to fail, then it should fail securely. And that authentication must be enforced server-side, not just on the client side. And number 4 is insufficient input and output validation. And this is a classic one. If your application accepts untrusted input from users, external files, or other applications without strict validation, then you are opening the door to injection attacks, logic corruption, or even remote code execution. And similarly, we should sanitize the outputs to prevent leaks or malformed states. Point number 5, or risk number 5, is insecure communication. That refers to broken transport protections. So if your application sends data over plain text, HTTP, or if it accepts any certificate without validation, then user data is vulnerable to interception. Every request must be made over HTTPS using a TLS 1.2 or higher with proper hostname verification, and ideally certificate pinning. And number 6 is inadequate privacy controls. Users expect their data to be protected and should not be mined. But applications often over-collect personal data, track users without consent, and even leave privacy settings buried. It's not actually about ethics only. It's about violating user privacy that can lead to regulatory penalties. So you need to design your app to collect only what is necessary and allow users to opt out and in if they so wish, and follow principles like data minimization. Then we have number 7, that is insufficient binary protections. When your application is released, you need to remember that it becomes accessible to everyone, including attackers. So without obfuscation, anti-tamper checks, and protections against debugging or runtime hooks, your logic can be extracted, modified, or abused. So you need to protect your binary like a product, because actually it is a product. And number 8, we are talking about security misconfiguration. And that is exactly what it sounds like. It means leaving debug code in production, misconfigured permissions, improperly exported components, or insecure platform defaults. A single misconfigured intent filter or content provider can become an attack vector. So it is critical to review and harden all configurations before release. Number 9 is insecure data storage. The still ranks high in mobile security issues. Too many applications store session tokens, PII, that is personally identifiable information, or credentials in shared preferences, or even unencrypted databases. If the device is compromised or if backup data is extracted, that sensitive data becomes exposed. You should use, therefore, encrypted storage and avoid local storage of anything you can fetch securely at runtime. And finally, number 10, we are talking about insufficient cryptography. This is about using outdated or broken algorithms like MD5, implementing your own encryption without understanding key management, or failing to properly secure encryption keys that renders any encrypted data useless. So you need to use platform-vetted cryptographic libraries and understand how encryption fits into your end-to-end threat model. These 10 risks are not abstract. They are based on thousands of real assessment, incidents, and research across both mobile platforms, that is iOS and Android ecosystems. This is the reality of mobile security 2024 as of 2025. Whether you are writing your first app or hardening one already in production, these categories give you a framework to build from. So in the coming videos, we're going to break down each risk with real-world examples, code walkthroughs, and best practices. And my goal has always been simple, to help you build mobile software that's not just functional, but resilient, secure, and respectful of your users' trust. So thank you so much for watching. Stay tuned and let's secure the mobile world one layer at a time. Bye.